is Forum Sanvi, and the topic I am going to present today is contrast enhancement of images using bi-equalization techniques. Whenever we write a paper or do a research, the foremost question that comes in our mind is what is the purpose or why are we doing this research? The purpose of my research is to carry out contrast enhancement on images. Contrast enhancement aids in bringing out the hidden details in the images which are of visual importance. For example, in cancer research, it is important that the doctors can diagnose the cancerous tissue from the normal tissues. Or in sonar images, detection of the object which can be overlapped by the marine wildlife is also important. The technique I am using for contrast enhancement in my paper is bi-equalization technique. But before we go into depth of bi-equalization technique, let's see what is equalization. Histogram equalization is the most simple and efficient method for contrast enhancement. Histogram means nothing but the plotting of the frequency or the occurrence of gray levels versus the discrete gray levels. Histogram equalization is performed sequentially. The first step is to calculate the frequency of the discrete gray levels present in the image. The second step is to calculate the probability density function, which is nothing but the ratio of the frequency of the discrete gray level divided by the total number of pixels present in the image. The third step consists of calculating the cumulative density function, which is done by taking the cumulative sums of the PDF values. For example, if you are given three numbers 1, 3 and 4 and you are asked to calculate the cumulative density function, then for the first value it is going to be 1, for the second value it's going to be 1 plus 3 that is equal to 4, and for the third it's going to be 1 plus 3 plus 4 equal to 8. These newly found CDF values are then used to form new gray levels, and these new gray levels gives us the equalized image. The drawback of the histogram equalization that noise and artifacts are added to it. To overcome the drawback of histogram equalization, we use the bi-equalization technique. Bi-equalization means performing histogram equalization twice. In this technique, the image is subdivided into two sub-images based on the mean value calculated from the image. That is, one of the image will have gray levels less than or equal to mean values, and the other image will have gray levels greater than the mean values. Then the histogram equalization is performed on the two images and finally merged to form a final equalized image. While merging the two images, care should be taken that when added, they just don't whiten the image. Hence, they are multiplied by some weighted constants. These weighted constants should be taken between 0 to 1 range. Bi-equalization technique can also be used in color image processing. Color images contain three color planes, red, blue and green. In this, all the three planes are separated and bi-equalization is performed on all the three planes. Color image processing is useful because the new technologies like the positive emission technology gives us color images, which gives us nothing but diagnostic images, and hence it's important that we do color image processing. From the figure, as we can see that the bi-equalized image gives us better result compared to the histogram equalization image where artifacts and noise has been added. Thus, we can draw a conclusion that bi-equalization gives me better results compared to histogram equalization. This research paper has broadened my knowledge in prospects of the field of image processing and signal processing. Thank you.